This is exercise 3.6 and question number 2, part number 1. It's a very important word problem, and before doing this word problem, I want to make clear you with these two words, downstream and upstream. If you know the concept of these two words, you can do this question easily. So downstream, before downstream and upstream, I want to ask you something. Have you ever felt a push when you're moving in the direction of wind?
Yes.
If the wind is blowing with a high speed, at a high speed, then you feel a push, isn't it? That means with your speed, the speed of air is added. That's why your speed is increased at that time. So here also in this question, the downstream means if the boat is moving, let's say in this direction, that means, and if it is, we are saying that it is, the boat is rowing in downstream, it means the direction of boat and the direction of water here is same. And at that time, the speed of boat and the speed of water will be added. So during downstream, the speed of boat will be increased because in the speed of boat, the speed of water gets added. That's why during downstream the speed is added. And in the same way, upstream means when the boat, suppose, is moving in this direction and water is moving in this direction, the current is in this direction, so both of them are in opposite direction, and at that time the speed of boat will be decreased, because from the speed of the boat the speed of the current will be subtracted. Okay, so let us suppose now, after clearing these two words, we'll have to suppose, let, it's the solution now. But before solution, I want to read the question for you. Ritu can row downstream 20 kilometer. The distance is 20 kilometer in 2 hours. How much is the time? 2 hours. And upstream 4 kilometer in 2 hours. Find the speed of rowing in still water and the speed of the current. We have to find out two things here. This is the first condition and this one is the second condition. And because we have to find out the speed of rowing in still water, means the water is not moving at that time, there will be no speed of water. At that time we call it as still water. And we also have to find out the speed of the current. So we will have to support these two. Let the speed of water in still water, speed of the boat in still water is x kilometer per hour, and the speed of the current is equals to y kilometer per hour. So we have supposed these two things, the speed of the boat and the speed of the current. Now we have to tell them what is the speed of boat when it is moving. Ritu is rowing that in downstream. So during downstream, the speed of the boat will be increased, and it will be x plus y. Both the speeds will be added and it will be x plus y kilometer per hour. And in the same way, during upstream, the speed of boat will be x minus y kilometer per hour. Okay, these are the speeds now, and we know we have a formula again, that is distance is speed into time. So this formula will have to apply for the given conditions, and the first condition is when the Ritukan rode downstream 20 kilometer. The distance is 20 kilometer, and the speed at that time, because she is rowing downstream, that's why the speed is x plus y. So speed here is x plus y, and time is 2 hour. So here the time is 2 hours. So according to the first condition, the equation will be speed into time is equals to distance. Okay, so this will be the first condition. And can you see anything here? Yes, we can cut it. So this will be x plus y equals to 10, and we'll get an easy equation. In the same way, we'll apply the second condition according to the second condition. At this time, the distance is 4 and the speed in upstream is x minus y, and the time is 2 hours. So the condition applies d equal to s into t, means distance equal to speed into time. So it will be like speed into time is equals to distance. Again you can cancel out, 2 2s are 4, and it will be now x minus y equals to 2, and this is the second condition. Now these two are the equations, and we can see that we can solve them easily by applying the elimination method. So I'm going to add these two equations. If you will add these two equations, y will cancel out, x plus x is 2x equals to 10 plus 2 is 12, and this will again cancel out, so this implies x equals to 6. And if you put the value of x in equation 1, we get what we get? Yes, we get 6 plus y equals to 10, or y is equals to
4.
10 minus 6, that is 4. So now we can write the answer. The speed of boat in still water, it is 6 kilometer per hour. You have to write the unit, otherwise you will definitely lose half marks. And the speed of the current is
4 kilometers.
4 kilometer per hour. And these two are the answers.